Prepare to have your mind expanded and your curiosity ignited as we delve into the extraordinary secrets and untold wonders of the Spitzer Space Telescope. Buckle up for a thrilling journey through the cosmos as we uncover 10 mind-blowing facts about this remarkable scientific marvel that will leave you astounded and hungry for more. Get ready to embark on a cosmic adventure like no other as we peel back the layers of the universe and reveal the hidden treasures that the Spitzer Space Telescope has uncovered, surpassing the boundaries of what we thought was possible. NASA's Spitzer Space Telescope is celebrating 15 years since its launch on August 25, 2003. This remarkable spacecraft has made discoveries its designers never even imagined, including some of the 7 Earth-sized planets of TRAPPIST-1. Here are some key facts about Spitzer. 10 things about Spitzer Space Telescope you didn't know. 1. Spitzer is one of NASA's great observatories. NASA's Great Observatory program aimed to explore the universe with 4 large space telescopes, each specialized in viewing the universe in different wavelengths of light. The other great observatories are NASA's Hubble Space Telescope, Chandra X-ray Observatory, and Compton Gamma Ray Observatory. By combining data from different kinds of telescopes, scientists can paint a fuller picture of our universe. 2. Spitzer operates in infrared light. Infrared wavelengths of light, which primarily come from heat radiation, are too long to be seen with human eyes but are important for exploring space, especially when it comes to getting information about something extremely far away. From turbulent clouds where stars are born to small asteroids close to Earth's orbit, a wide range of phenomena can be studied in infrared light. Objects too faint or distant for optical telescopes to detect, hidden by dense clouds of space dust, can often be seen with Spitzer. In this way, Spitzer acts as an extension of human vision to explore the universe near and far. What's more, Spitzer doesn't have to contend with Earth's atmosphere, daily temperature variations, or day-night cycles, unlike ground-based telescopes. With a mirror less than 1 meter in diameter, Spitzer in space is more sensitive than even a 10-meter diameter telescope on Earth. 3. Spitzer was the first spacecraft to fly in an Earth-trailing orbit. Rather than circling Earth as Hubble does, Spitzer orbits the Sun on almost the same path as Earth. But Spitzer moves slower than Earth, so the spacecraft drifts farther away from our planet each year. This Earth-trailing orbit has many advantages. Being farther from Earth than a satellite, it receives less heat from our planet and enjoys a naturally cooler environment. Spitzer also benefits from a wider view of the sky by orbiting the Sun. While its field of view changes throughout the year, at any given time, it can see about 1/3 of the sky. NASA's Kepler Space Telescope, famous for finding thousands of exoplanets, planets outside our solar system, also settled in an Earth-trailing orbit 6 years after Spitzer. 4. Spitzer began on a cold mission. Spitzer has far outlived its initial requirement of 2.5 years. The Spitzer team calls the first 5.5 years the cold mission because the spacecraft's instruments were deliberately cooled down during that time. Liquid helium coolant kept Spitzer's instruments just a few degrees above absolute zero, which is minus 459 degrees Fahrenheit or 273 degrees Celsius, in this first part of the mission. 5. The warm mission was still pretty cold. At the warm temperature of minus 405 Fahrenheit, 2 of Spitzer's instruments, the infrared spectrograph, IRS, and multiband imaging photometer, MIPS, stopped working. But 2 of the 4 detector arrays in the infrared array camera, IRAC, persisted. These channels of the camera have driven Spitzer's exploration since then. 6. Spitzer wasn't designed to study exoplanets, but made huge strides in this area. Exoplanet science was in its infancy in 2003 when Spitzer launched, so the mission's first scientists and engineers had no idea it could observe planets beyond our solar system. But the telescope's accurate star targeting system and the ability to control unwanted temperature changes have made it a useful tool for studying exoplanets. During the Spitzer mission, engineers learned how to control the spacecraft's pointing more precisely to find and characterize exoplanets too. Using what's called the transit method, Spitzer can stare at a star and detect periodic dips in brightness that happen when a planet crosses a star's face. In one of its most remarkable achievements, Spitzer discovered 3 of the TRAPPIST-1 planets and confirmed that the system has 7 Earth-sized planets orbiting an ultra-cool dwarf star. Spitzer data also helped scientists determine that all 7 planets are rocky and made these the best understood exoplanets to date. 7. Spitzer is a window into the distant past. The spacecraft has observed and helped discover some of the most distant objects in the universe, helping scientists understand where we came from. Originally, Spitzer's camera designers had hoped the spacecraft would detect galaxies about 12 billion light-years away. Spitzer has surpassed that and can see even farther back in time, almost to the beginning of the universe. In collaboration with Hubble, Spitzer helped characterize the galaxy GN 11, about 13.4 billion light-years away, whose light has been traveling since 400 million years after the Big Bang. It is the farthest galaxy known. 8. Spitzer discovered Saturn's largest ring. Everyone knows Saturn has distinctive rings, but did you know its largest ring was only discovered in 2009, thanks to Spitzer? Because this outer ring doesn't reflect much visible light, Earth-based telescopes would have a hard time seeing it. But Spitzer saw the infrared glow from the cool dust in the ring. It begins 3.7 million miles, 6 million kilometers, from Saturn and extends about 7.4 million miles, 12 million kilometers, beyond that. 9. The beyond phase pushes Spitzer to new limits. In 2016, Spitzer entered its beyond phase with a name reflecting how the spacecraft operates beyond its original scope. Spitzer, which launched August 25, 2003, will begin an extended mission, the Beyond phase, on October 1, 2016. As Spitzer floats away from Earth, its increasing distance presents communication challenges. Engineers must point Spitzer's antenna at higher angles toward the sun to talk to our planet, which exposes the spacecraft to more heat. At the same time, the spacecraft's solar panels receive less sunlight because they point away from the sun, putting more stress on the battery. The team decided to override some autonomous safety systems so Spitzer could continue to operate in this riskier mode. But so far, the Beyond phase is going smoothly. 10. Spitzer paves the way for future infrared telescopes. Spitzer has identified areas of further study for NASA's upcoming James Webb Space Telescope, planned to launch in 2021. Webb will also explore the universe in infrared light, picking up where Spitzer eventually will leave off. With its enhanced ability to probe planetary atmospheres, Webb may reveal striking new details about exoplanets that Spitzer found. Distant galaxies unveiled by Spitzer, together with other telescopes, will also be observed in further detail by Webb. The space telescope NASA is planning after that, WFIRST, will also investigate long-standing mysteries by looking at infrared light. Scientists planning studies with future infrared telescopes will naturally build upon the pioneering legacy of Spitzer. As we bid farewell to the captivating journey through the lesser-known secrets of the Spitzer Space Telescope, we are left in awe of the extraordinary discoveries it has unveiled. From its ingenious use of infrared technology to peer through cosmic dust clouds, revealing hidden stellar nurseries, to its role in identifying and characterizing exoplanets, this unsung hero of space exploration has forever altered our understanding of the universe. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.